with a DSM-4 diagnosis of bipolar disorder were randomly divided into two groups. All right. And yes, this bipolar disease, drugs like this will be used to help these individuals, but they wanted to randomly divide these into the two groups. So how many they put in group one? And when they put group one, they put 55 of them. Group two, 60. Okay. Well, who's getting the real deal? This was a double-blind experiment. Who's getting the real deal, the real drug? Who's getting a placebo? Whoops. This is the experimental group right here. They're getting the real thing. Treatment group, experimental group. Control group, placebo. And these two numbers, they put 55 of them here, 16 here. But all these 115 individuals who prior to this were already diagnosed with bipolar disorder. All right. You're getting a placebo, you're getting a real thing, it's a double-blind experiment. Okay. They received 5 to 20 milligrams per day of olanzapine. The effectiveness of the drug was measured using a Young Mania rating scale. Total score with the net improvement, the score recorded. And here's the results. So this is mean improvement. Mean improvement, this is by the Young Mania scoring method. 14.8. Standard deviation, 12.5. How about the mean improvement for the control group? Aha. Well, we already can see a difference, correct? Mm-hmm. And when we know what we're doing in this class, we want to see, are the results statistically significant? We can see there's already a difference in the means. But are these results statistically significant? Did they use a 5% level of significance? Everyone, I apologize, I kept this up from before. This is what usually happens when they're testing these drugs. We're using a 1% level of significance. A lot of times we use something that low. So I do want to point out for this problem, level of significance is 0.01. This was 12.5. This standard deviation is about the same, about 12.7. All right. Now let me ask the question, everyone. Experimental group, control group. And you're going to help me set up this hypothesis test. I'll say this a couple times. Does the evidence suggest that the experimental group experienced a larger mean improvement than the control group? Say it again. Does the evidence suggest that the experimental group experienced a larger mean improvement than the control group? So when I set this up, we know that's the null hypothesis, right? Mm-hmm. Equal means. Population means are equal. But they just said, we're going to check alternative hypothesis. Is this mean greater than this? So what do y'all think? This isn't two-tailed. This one greater than this one, right? Mm-hmm. This one greater than this one. So I'll do, whoop. Sound good? Greater mean improvement. That's what the question was. Not just because that number was there, but that was the original thought. You know, hey, they do better with this drug. Olanzapine. They were given 5 to 20 milligrams a day. All right. Everyone, do we have to go through and maybe make those normal probability plots this time?
No.
We're good. Are these sample sizes greater than 30?
Mm-hmm.
Yeah. Yep. Hey, N1's greater than 30? N2's greater than 30? Didn't they say they were randomly placed in these two groups? Mm-hmm. They were randomly assigned? We're good. We are good to go. That was quick. Sometimes they just can't get 30 people though sometimes, in certain circumstances. This stuff costs a lot of money. You ready? We're going to do the classical approach, then we'll do the p-value approach. Very simple. If our p-value is low, check that out. It's got to be lower than 1% though. All right. We'll do the classical approach. I'll get my bell ready. T, right? These are means. T equals 0 here, t equals 1, and t equals 2, and t equals 3. Don't find your t crit. How much am I shading over here? 0.01. Thanks, Michael. Now we're going to get a t crit over here. 1% level significance, right? But t crit isn't 0.01. I got to get it from the table. You're like, okay, well, what's the degrees of freedom? All right, let me explain this. All right, let's say I didn't have that cool button. I would use sample size 55, degrees of freedom 54. That's what I would do. It would, in art, it would be good enough. It'd be close enough. But I'm going to use the technology because it can use that math formula to find the degrees of freedom. Is everyone ready to roll with this? You know where we're going. 2 sample t-tests. These are independent groups. Independent groups. These are not matched pairs. You know? 55 and 60, 2 different groups, randomly assigned. They've all been diagnosed with the bipolar disorder. Stat, test, t-test, nah, we did that with matched pairs. This is a 2 sample t-test, independent samples. Data or stats? Stats, excellent. And when this time we don't have the data. Thank God. Right? L1 would have 55 of them. I don't feel like typing that in. All right, what's X bar 1? Somewhere on that table. Where is it?
14.8.
14.8. What's SX1?
12.5.
12.5. What's N1?
55.
55. What's X bar 2? 8.1. SX2.
12.6.
And N2. 60. Which one of these do I want?
Greater.
Yeah, I went greater than, right? Excellent. Right? Is that the end of the list? Nah, I still got it down there. It's long because we had to enter all that. Do we pull here?
No.
Never pull, never pull, never pull. Calculate. It's called a Welch's t-test. We don't pull. Unless I had knowledge about the variances. We don't. We don't. I want to stare at the p-value. Stare. Is that lower than 0.01? Reject null. There is evidence, right? Suggesting that drug, the mean for that group, experimental group, is greater than the mean for the other group. Seems like the drug's doing its work. Hey, look at the DF. What's the degrees of freedom?
112.
This came, remember, it comes from that math formula. So when you look at it, you go, what? Came from that funny formula I put on the board. So I'm going to write that down. The degrees of freedom was a 112 point what? 4. I'll put all these numbers down. We'll wrap up this stuff. Degrees of freedom, 112.4. Okay. What was the p-value? 0.002. So the only thing I use for the yellow chalk is the alpha level significance, where I shade the tail or tails, and my degrees of freedom. That's all I use for my yellow chalk. Everything else is white chalk. P-value is this. Let me find that test statistic. What was that? 2 point what? 849. I'll put 8 what? And you betcha. You go, well, what's the t crit so we can compare? Well, I need to use the table. Unless you got inverse t.
T crit will be less than 2.85.
Ooh, thank you.
Right?
So Ryan's going to hit inverse t. He could just hit 0.01 and put it over here and then put it negative, and then he's going to just be changed to a positive. He can just do that right there. But I'm going to use this table. I want 100. What's the closest to 112 on this table? 100. Check out the 0.01.
2.36.
2.364? 2.364 is the t-crit from the table. I mean, it was close, everyone, but this is in here. There it is. It's in there. It's in the region. Right? This p-value is lower than the alpha level. Because the p-value is lower than the alpha level. What are we doing in reference to the null?
Rejected.
We reject the null hypothesis. So my conclusion, my concluding statement, is there evidence?
Yes.
Yeah, oh, there is sufficient evidence. Suggesting, you go suggesting what, right? You can try this. That's okay, because you've already referenced that this is group 1, this is group 2. It's the mean of group 1. It's greater than the mean of group 2. It's Tim's just scoring on this test. Now if you want to put words, the mean score of the group taking the drug scored better than the mean group, or the mean group for the group using the drug is greater than the mean for the group, for the control group. If you also want to reference the alpha level, what was the alpha level again? You can put that if you want. At the 0.01 level of significance.
The lower the level of significance, the more accurate it is, right? The
That's
test?
right.
That's-
Yeah. And they use 0.05 all the time, don't they? It's
Yeah.
common. Standard. It's like the standard level
I think
significance.
for medicine they use.
He's
the-
noticed, and when they're in medicine, sometimes you're using a 1%. And you go, what does this mean? We're saying anything under 1%, we're going to look at as unusual. You really not 2%? They just want to be safe, right? They want to be sure. So super job with this stuff, everyone. This is inference about two means. We just did inference about two means last class, last section, but that was matched pairs. Everything was paired up. In this case, not the case, right? Any questions on any of this stuff? Better p-value. We spoke about the p-value. We stated our conclusion. You have done everything. Cool. Isn't it all this stuff with hypothesis testing? It all goes together. We look at these p-values. We check. We look at the critical region. This has to go hand in hand with this. It all works out. Yeah. Well, everyone's super job at this stuff. Hey, next class will be just Tuesday. We do have class. We'll be reviewing for the final. And come in. Anybody want blank tests just to practice from? They're in Canvas. Now you're like, but I want to check over the weekend if I got a problem right or wrong. I put the solutions to the tests in Canvas, so you can check the solution documents.
Do we have the answers to
Yep, I got all the answers. Now, here's
This is
something
final.
else. Oh, he wants the answers to final. The only thing I didn't put there. Hey, one more thing. If you're like, I want some more practice from this, because we haven't done this yet, I put a document, some practice problems from this material. If you want to do that. So you'll see that, Chapter 11 practice. Great job, everyone.